Hey everyone, thanks for coming out today. Just before we get started, I'm going to tell you a little bit about myself, a nice story that Andy refused to tell because he's a nice guy. A few months ago, we were in New York together at the MongoDB World Conference, and we just were meeting with some executives, directors from MongoDB, and one of the people we met with, I had no preparation for. He's like, oh, we're meeting with this guy named Elliot. I was like, yeah, sure, cool. So I sit down with the guy, I'm like, so what do you do here? And he's like, oh, a little bit of marketing, sales, development, pretty much everything. And I was informed later that he was the founder of Mongo, so that was kind of how I got started here. Also, I'm a huge fan of shellfish. If you want to bribe me for anything, just put some oysters in front of me, and I will do whatever you tell me. Before we get started, I'm going to do a Halliburton tradition, which is a safety moment. All the presentations we do, we start with this. Today I'm going to talk about flood safety, because it is a problem we deal with here in Houston, especially as we head towards hurricane season. As you can see from the chart, we've been trending upward, unfortunately, in the number of flood days we have per year in Harris County. And it's important to know, before you leave your house, what kind of weather you're going to deal with that day, because a lot of times we get these flash floods that come out of nowhere. It's sunny in the morning, and all of a sudden, a foot of rain is on the ground. So make sure that when you go out, you check the weather. And I recommend to have like a hammer or something in your car to break your windshield. I know that some cars that are newer, you can take the headrest out and bash the window in with it. But one recommendation that I read recently online that I did not know before is that before you get out of your car, if you are trapped in water, make sure you spot land first, because you don't want to just start swimming and tire yourself out endlessly going in the wrong direction. Today I'm going to talk about the overall well construction initiative at Halliburton. So going from plan to design to execution. Then I'll get into what we do on the Edge platform itself, and talk about kind of how we went from our traditional data model to MongoDB. We're going to talk about how we leverage MongoDB for that solution, and then how MongoDB has impacted our daily project work. Traditionally, with well construction, it's been separated between the plan and design phase and the execution. And we wanted to kind of find a way to eliminate the man in the middle, per se. Usually what would happen is we were drilling, something would happen, like a vibration issue or bitware issue, and we would stop drilling. Someone at the oil field would call the back office, or either the back office that was monitoring the WITSML stream would call them and say, hey, something's going on, we need to do some reanalysis. And what we wanted to clean up there is how do we make it a little bit faster? So we came up with the idea of the Edge box. And this Edge box is a tool that accepts data from the back office, like the current plan, applies those models for coming up with drilling parameters or completion parameters or production parameters, and automatically feeds that information to a rig automation interface, which is being stood up by many of the rig contractors today. So where does this all fit in with the ONG process for drilling? So if you think about, there's 5 levels of communication that occur, and this is taken from the Purdue automation pyramid that was published in 1990. They start with the physical process of, you have a hammer hitting something or a drill going into the ground. That is generating the physical data that a sensor would pick up. And the sensor sits right on top of that level. That could be a PLC reading analog sensor data, or a DAX board doing the analog to digital conversion into a rig control system itself. And usually that's what a driller would see on the HMI. We've developed a platform that sits right on top of that, and that's where you see Halliburton Edge at the control and supervision level, where we communicate with rig automation layers. And the reason why we wanted to sit so much closer than our traditional applications is that we wanted to reduce latency and allow us to quickly react to change. The majority of applications, such as what EDRs like Payson and WITSML use, sits at the application level, which maybe 1 per second with some 15-second plus latency on the data itself to retrieve it. But by sitting closer to the equipment, we can reduce that latency to 1 to 2 milliseconds, which allows for the high-speed reaction. And finally, when we look at enterprise, we want to get data back into the data center, process it, put it into our data lake, update our models, look at how we can improve our next jobs, but also while the current job is running, how can we rerun our simulations and provide data back to the rig to improve our current results. So the four-step process we took a look at it, implementing the edge solution, was one, how do we solve the data problem? And it's a problem that we all deal with. We have so many different data models that exist from everyone to get data into our system, and that it was something that was bogging down our applications. We were always having to upgrade to the latest version of a protocol, application by application. There were some applications that certain customers used using WITSML 1.3, for example, and now they wanted 1.4. Now we have to upgrade the application, but our other applications still only accept 1.3, so we can't use them for those jobs. And what we wanted to solve by integrating an IoT-type solution is data standardization to allow us to pull all that data in separately through a singular platform, and then all the applications running on that platform would no longer have to worry about where their data come from or what it looks like. They always use the same data contracts. Once we got the data into the system, it still isn't time synchronized, so we had to add data processing on top of that. And that data processing a lot of times would be like a 1 per second clock that would take the average of data or the last value we got, or sometimes 10 per second. And that would be spun into our persistence layer. That persistence layer right now is in transformation to MongoDB, and I'll talk about that a little bit more later. But the other tenet of this is that we have edge apps and analytics that use that data, and each of those apps has its own need for different data sets. And so we used a very domain-driven data model where each microservice that was doing analytics would save its own data into a separate MongoDB instance. That data would then be fed to dashboards. And one of the great things about having that data tied directly to how the analytics were running is that the dashboard could do a query against an API and get specific data back very quickly. The final piece is remote transmission. We want to get our data back to the data center, and Halliburton's Optimus project is going to provide the ability to get data bidirectionally so that we can do what we talked about on the previous slide and do closed-loop automation at the rig site. The way that we accomplished a modern architecture is by looking at a container management orchestration model. We wanted to have full stack service integration. So instead of building monolithic applications that were very heavy and couldn't be scaled, we wanted to build a solution that could run both at the data center and on edge. And the easiest way to accomplish that was utilizing Docker containers. So we started building out all the different pieces of our edge platform, and we ended up with 25 different repositories in Git, which led to 25 different Docker containers. And 15 of those get deployed as edge platform components, and then we have some user interface framework components that get deployed underneath that. And the beauty of this is that we can quickly develop applications in a matter of days now instead of months, and put them out in the field for testing and then eventually production. The modern pragmatism for CI/CD is something that we took to heart, but it's very difficult to do that in a field environment because we don't want to risk that in the middle of a job something gets upgraded or breaks an existing solution that's working. And so we enveloped the CI/CD pipeline mechanism, but if you notice, we took the deploy piece and we kept it out of that model. We have an on-demand deployment mechanism that we built in-house, which allows us with a one-click installer to publish Docker containers over the network, either locally or remotely, onto a system that's running at the edge. That's something that we think is very novel, and it allows us to still have fully integrated testing as if we were doing cloud development, but it also lets us now have a singular standardized environment for deploying new software to our systems. One of the wins that came out of this, especially with the CI/CD piece, is we had a hackathon last week, and we wanted to show all of the service lines in Halliburton the power of this CI/CD model and developing on our drilling platform. And so we gave all those service lines, there were 13 individuals that came, 4 hours of training on it. And we said, here's the APIs, here's the data contracts we're going to use, here's the SDK you can use. We have a couple languages we support. And we told them, okay, now that you've gone through this training, you have 6 hours, go build a drilling optimization app. And each one of them was given a simulator and an edge instance up in the cloud running on Docker to work with. And they started working on their apps. And what was cool is, they could just rerun and rerun that simulator. It only ran for 12 minutes at a time, and it was running at 10x speed. So we saw a lot of different solutions, like people doing ML training, deterministic models. We saw people finding boundary constraints and applying them immediately to the next round of simulation, which was kind of, for us, a simulation of offset well analysis. How do you take previously learned data, create a model, and then make a better result next time? And what was pretty cool is we had people drilling 600, 800 feet in that 12-minute period at 10x. And when they would start, they'd be at 200 to 300 feet. But because of this optimization and how quick they could build their application, not worry about, is the platform going to give them data in WITS? Is it going to be an OPC? Is it going to be Modbus? That could all be accomplished relatively quickly. So at the end of the hackathon, we had 13 individuals all successful in building an app, which was something very special for us. How did we get to MongoDB? So we kind of knew that we had a need with IoT data that store things unstructured. And when I say that, I mean that the structure of the sensor data that we're receiving is structured, but we don't know what sensors we would be receiving each job. And therefore, we needed a way to kind of dynamically build this. And the first pass at this was, OK, I know how to do SQL. The rest of my team knows how to do SQL. Let's try to build a lookup table for this, do some PK-FK relationships, and see how fast we can spin something up. And it was like a month of toiling around. We finally kind of built something, and then we found another use case that was like, oh, shoot, this breaks our whole data model. And unfortunately, on our team, we didn't have a DBA. We just had a few developers. None of us had that background experience, so we started Googling what are our options for doing this non-schematic data that was unstructured. And through that investigation, I kind of came across MongoDB, and it was really easy just to kind of spin it up. I started off with Compass, which was shown earlier, and started building a document by hand. And after just a few hours of toiling, I had built my first pass. So something that took me almost a month to do, I replicated in MongoDB in just a few hours. And that's kind of when I knew, like, this is the way to go. But I still didn't know if the performance was going to be good enough. And by starting to feed data, and that's when I really saw, like, wow, like, even compared to my SQL queries, this is really keeping up with it. The big benefits I got out of this, though, that we've carried forward to our future solutions that we're building on the Edge platform is that we can build faster prototypes. One of the biggest issues we had before is we would always store things in a text file or in memory because it was such a pain to build our SQL schemas. But now with Mongo, because the domain-driven development can be applied directly, whatever we had, and most of our stuff is Node.js, so it was already JSON-based. It was just minutes to take a JSON object and put a schema for Mongo and persist it. The other thing that kind of struck me was the community support. When we were looking on Stack Overflow, there was just an answer for everything. And that's just one of the key benefits that we found when we chose it. The other thing that kind of impressed me about MongoDB, which I had this big problem with SQL, that there's not enough drivers for it. Like if you want a Java driver, you have to use JDBC. If you want a C# or VB.NET driver, it's easy. But then when you get to like Node.js and Python, there's like nothing. It's very difficult to use. It's all low-use products, but they actually have enterprise support for their drivers in almost every language I use, including like Golang, R, Python, and Node.js. So that was a big deal for me. The way that we use MongoDB is a few different phases. So we start off with the caching system as our initial use case. So we wanted basically our user interfaces to be able to refresh and still show the same data as before. We have an EDR that we have built in-house that I mentioned before that we're currently transitioning to MongoDB that stores our large amount of data sets, but it's not the best place to do queries all the time. It's not meant for that purpose. So what we did is we built a streaming data solution that stores short TTL data into Mongo. And then when our websites refresh, it calls an API that queries that small, like 5 to 10 seconds amount of data from Mongo, pulls into the user interface really quickly. The real-time streaming data solution, even though we do have that EDR available, we found certain things we wanted to place into that database. For example, like what is the current rig activity? That's a calculated value. We didn't really have a place to store it in our EDR. So we started taking 1 second averages of a voting system of different applications, what they thought our data was, storing all of their data in, and then aggregating on the way out to figure out what we thought the current reactivity was. And then the other use case we have for Mongo was kind of like a microservice settings store. So when our microservices load up the first time, they have default configuration, but we have APIs to configure those microservices. And initially, we were updating the text files, or we were storing just in memory what those configurations were. And of course, the problem is if your microservice goes down and comes back up, you lose that data, or as you implement new versions of that configuration, you're going to have issues with which text file is valid, how do you upgrade that file if you see it, et cetera. And then also clearing and resetting the defaults. Now I don't have my original file anymore. So that's a big win for us. The final thing is transient data storage. So MongoDB we found was fast enough for most of our things that if we don't want to store things in memory, and we wanted a way to share between scaled services, we can just pop things on the Mongo real quick and pop them off when we're done with them. And through that, we can now start having 2 to 3 services running at the same time. They query Mongo to get whatever the transient data is, and that way we don't have to worry about memory map issues. So how did we get started with Mongo? It was actually really simple, and the easiest way, and for those of you who haven't used Mongo before, that I recommend trying out is to get onto Docker Hub and download one of the images, and I'm going to actually show that in a minute. You can just do a one-line command, and you'll have MongoDB running. So real quick, I'm just going to show. I have a Linux console running here, and I can just say docker run -it-p and expose the Mongo port, which is 27017. See if I can make this bigger. Sorry for the small print. And then I can say Mongo, and I'm saying, give me the latest of version 4. So just by running this, I now have a running Mongo. It took me about 3 seconds. I can go to Compass, and I can put in the IP address of this machine. Press connect, and now here's my Mongo database. I can start playing around. So that's exactly what we did. We started coming to here. We started creating new database records, playing around with the schema. Then eventually we added the Docker volume so we could persist it. So I'm going to talk about one lesson learned from us that was kind of a consulting job that we did with Mongo to help us improve our performance. We wanted originally to store, as I mentioned, like 1 per second data of certain items. And we, being a former SQL developer, I did exactly what I said not to do earlier, which was build a like PK type document. So I had my ID, source ID, sensor data coming in. I had the timestamp of the data, and I had my values in an array or in a complex object, depending on what it was. And what we found was that for the first few 100,000 records that were stored, there was no issue. We were seeing 2 to 3 millisecond latencies on the queries, and that was great, no problem. But as soon as we started hitting closer to 700,000, a million records, and we were querying that, we would see 20 to 30 milliseconds of latency, and then it got bigger and bigger exponentially. And so after looking over how we were persisting our data, what was recommended to us was that we would move the source ID out and actually name that as the collection name. And that's like something that sounds crazy, right? A table with a source ID name in it. But by doing that, now we had a common format. So we said whatever the data name was underscore the source ID for the collection name. When we specifically look for that information. And then now our document became much smaller. It only has the values, and the ID, we moved as timestamp. So it was very quick to look up what is happening from this time to this time in document form, and then aggregate all the values and average them, or make a chart of the historical change. So what was the overall impact of using MongoDB on our project? The first and most important to us is that there is less time between the start of development and when we persisted data. Because we don't have to design a full DBA schema every time we want to do something, we can just start throwing our data from the first iteration into Mongo. And because it usually matches our domain model directly, there was no worrying about, are we going to break something in the database, or we're going to break something back in our domain on reading. It just was seamless. The other thing which I really like as a dev lead is that my developers were more aware of the whole picture of what was going on in the application because the domain and the persistence schemas were being developed by them. So since it's the same person, there was no going back and forth trying to figure out, okay, why doesn't my data persist? I got this in Hibernate error. There's nothing working. Some data is persisted in the wrong format. I thought this was supposed to be an integer, but there's actually a char 32. Those different things no longer happen. And then because I know my object model, I can specifically make my Mongo schema related to the domain types that I store. The other benefit I got out of this was that changing schemas mid-development no longer was scary for me. Before we kind of used to massage our data to fit into whatever schema we started with because I was so afraid that if we changed the data schema, we would break all of our historic data. And now we can know that we can add new variables onto the document without breaking anything. We can add new collections side by side with existing ones without having any issues. All those things became just so much easier for us afterwards. And finally, we spent less time on data mapping and more time on domain structure. So as I mentioned with the domain-driven development, we aren't really thinking about what is my database going to look like. We're thinking about how does my application want to run. So I'm thinking more now about my API side. Someone that's calling my REST API, what do they want? I take that information and I persist it just like that in Mongo, and that's a huge performance benefit, both on the actual runtime of my application, but also on the development, because it becomes a lot faster. So I wanted to leave a bunch of time for questions about the platform or anything related to Halliburton. So anyone have anything?
I have one.
Okay.
What are some of maybe the other use cases that MongoDB can help you with going forward?
Sure. So one of the biggest things for us is transmission of data. And we have a gap between what's currently stored on our edge box and what's stored in our data center. And so one of the biggest benefits we'll get out of MongoDB's capability to replicate across different locations is now we can treat our edge and data center as a singular database. And so as we limit the amount of data that's coming onto our edge side, we can push that data immediately to the data center. Okay. Any other questions?
So how do you plan on managing validation in the future going forward in terms of the edge platform that you're able to get at the data center?
Okay, so I think the data center has to be stricter than the edge does because the edge's lifetime is usually 3 weeks to a couple months, which is the length of a job. But as the data center itself needs to store data long-term, possibly years, so that we can build a big data lake to do machine learning and other things on, I think MongoDB helps with that a lot because with the lose my microphone. There it is. We don't have to worry as much about breaking changes like stranded records or let's see, battery dead. It looks like we had a dead battery or something, so stand by. Can you guys hear me now? All right, cool. So with the schema-less model, we don't have to worry as much because those changes can be stored separately. We can split a collection into multiple. We can start a new database, and just like what they showed with the S3 stitch model is that you can take that historic data, put it somewhere, and that schema will be accessible. Now I maintain that from my API side. It's no longer a problem with corrupting my database. Okay. Any other questions? All right. Thanks a lot, guys.